Hi everyone. Gonna go over the PowerPoint for week 9. It's just essentially adding cross cylinders and introducing torque transposition. Two really easy concepts. Page 147 and 148 in our text. Adding cross cylinders, we're basically just elaborating on the optical cross. So we're going to follow these steps. You're going to create an optical cross from the two RXs. We're going to add the vertical components together, then add the horizontal components together. And then when we have our new totals on the new optical cross, we essentially just take it off the optical cross in plus and minus cylinder form. Really straightforward. So here's an example. You have a plus 5, plus 75, and a plus 75, plus 50 at 180. Put them on the optical cross. You see the plus 5 goes with the 90, and then we transpose and get 575 at 180. At 180 we have a plus 75, and at 90 we transpose and we get a 1 1/4 at 90. So basically we're just going to add a cross. So 5 plus 1 1/4 gives us 6 1/4, and plus 575 plus 75 gets us 6 1/2. So we have this new optical cross, and we basically take our prescription off, and we get this in plus cylinder, and we get this in minus cylinder. So here's another example. You can see it's pretty straightforward. The main thing to keep track of here is your axis. Make sure your 180 and your 90, or whatever your two axes are, that you keep them consistent. Last thing you want to do is get one of these two mixed up. Next we have the nominal power formula. So this is segueing into torque transposition. So we remember the nominal power formula. It's the front surface plus the back surface equals the total power. The part of this formula that we're going to focus on is this here, how to calculate for D2, the back surface power. Because when we have a lens with cylinder in it, the back surface has the toric curve, which is the curve that handles the cylinder. So this is the the formula that we're going to focus on. This slide is just, a refresher on different lens designs where we can have a plus in the front, minus in the back, plus and plus, minus and minus. It's just a refresher. But remember, D1 is the front surface and D2 is the back surface. D1 is also known as the base curve. Okay. This slide is just breaking down the nominal power formula again. This slide here is using the nominal power formula with an example, just as a reference for you. This slide here, another example. This one here is a good example because this is actually solving for the back surface power. So this is saying the lens has a nominal power of plus 350, a front surface of 9 1/4, a base curve of 9 1/4. What's his back surface power? So following the formula, we take the nominal power and subtract it from the front surface, and we end up with a minus 575. For us, D2 is also going to be known as the toric base curve, which is the flattest curve on the back side of the lens. Okay. So toric transposition, what is this? This is basically telling us what curves or what powers are going to be ground on the lens during the manufacturing process. So if we look at a lens here, we know the front is going to be a plus power for this particular lens. The base curve is plus. The back side of the lens is going to have minus power, and basically, we know that with something that has cylinder, the backside is going to have two curves on it because toric means more than one curve. So on the top, we're going to have the toric base curve. And on the bottom, we're going to have what's called the cross curve. And the cross curve is basically just the cylinder that's left over. It's the steepest curve on the backside of the lens. So some rules here. For minus cylinder, which we're going to be doing most of the time, the base curve will always have a plus power. For plus cylinder form, the base curve will have a minus power and will be on the concave surface. So basically what they're saying, if it's a plus cylinder, we're just going to draw this backwards. So it's saying the base curve will have minus power and be on the concave surface. So the base curve would be there, and then you would have your toric base curve and cross curve. And I believe you can put on either side too. Could also look like that. Okay. So again, we're going to be doing minus cylinder form most of the time here. Number 2, the spherical power of the prescription will be the flattest curve of the lens. This is also known as the toric base curve. All right, we identified that. The cross curve is the amount of prescribed cylinder plus the toric base curve. So the cross curve is the toric base curve plus the cylinder in the prescription. So let's look at a typical toric transposition diagram. So we'll have the base curve on one side, the toric base curve and the cross curve on the other side. And this is if the base curve is plus, make sure the RX is in minus cylinder. That's very important. That's the main thing that will trip most of us up. All right. So some definitions. The definition of a base curve is the curve from which all other curves will be calculated. That's a very typical ABO, any kind of test question. That's a very common one. The toric base curve is the flattest curve on a toric surface, and the cross curve is the steepest curve on a toric surface. Remember, the toric base curve will be the lower power curve on the back, and the cross curve will be the higher power curve on the back. Okay. So here's a sample prescription. How to find the curves. So the base curve is either going to be given in the question, or we need to remember Vogel's rule. Vogel's rule for a plus lens is the spherical equivalent plus 6, and for a minus lens, it's the spherical equivalent divided by 2 plus 6. So you'll always be able to find out the base curve either given in the question or using Vogel's rule. On the back side, the toric base curve, remember, we're solving for D2. It's basically just using this formula here. And the DRX is also known as the sphere power in the prescription. And then D1 is also known as the base curve. And then the cross curve is basically you just take your answer from the toric base curve and add the leftover cylinder. So in this particular case, it would have just been D2 plus the minus 1 1/4.